All right, class, we're going to talk today about what we call as binomial theorem. And binomial theorem I want you to think of as just a quick way to multiply polynomials. So we're kind of going back in time and multiplying polynomials now. This is going to help us multiply polynomials that can take a long time, but with binomial theorem, it kind of speeds up the process. So what you're seeing here is a special triangle, and this triangle here is called Pascal's triangle. So let's write that down. Pascal's triangle is a very simple idea, but it actually helps us do some quick multiplication that otherwise would take us a little bit longer. So if we start here at the top, this row is called actually row 0, okay? And you see the number 1. This row here is called row 1, row 2, row 3, row 4, and so on. So hopefully you can start seeing the pattern. In Pascal's triangle, we take the previous row to help us get the next row. For example, to get the next row, we take the previous row and bring those numbers down. Okay? To get the third row, we're going to bring these numbers down to the edges here. But to get the middle term, we're going to bring the numbers also at the middle. And since there's 2 number 1s going to the middle, we add these numbers together to get 2. To get the third row, same idea. The number 1 goes down. The number 1 goes here, 2 here, 2 here, 1 here, 1 here. So essentially, these numbers drop down to whatever next number they are touching. So to get this row, we bring 1 down here. 1 and 2 together, so 1 plus 2 gives me 3. 2 plus 1 gives me 3. 1 by itself gives me 1. And so on. The next row, here, 1 and 3 will give me 4. 3 with 3 will give me 6. 3 with 1 will give me 4. And then 1 comes over here. And we continue this pattern, and this is how we create Pascal's triangle. So just real quick to make sure we understand, in order for me to get 10, I had to add the previous 2 numbers above number 10. To get 15, I had to add the previous 2 numbers in the previous row to get 15, and so on. So this is how you create Pascal's triangle, and as you can see, it's very easy to create, but it also can help us multiply. Okay, for reference sake, I've listed the rows. So this, again, row 1. The second row is actually row 2. The third row is actually second row is row 1. Third row is row 2, and so on. So if I say look at row 4, you're looking at this row right here. Row 7, you're looking at this row here. So the thing that throws it off a little bit is the first row is not row number 1, it's actually row number 0. So I want you to take a peek here. In this binomial, we are adding 2 numbers or letters or variables, and we're raising it to a certain power. Okay, so in this case, we're going a plus b to the first power. If we did this math, this is what a plus b would look like. If we did a plus b to the second power, that essentially is a plus b times a plus b. And if we multiplied this out, we would eventually get this. Okay? So let's skip down to a plus b to the fourth. What this is a plus b times a plus b times a plus b times a plus b. If we had to multiply this out, this would probably take a long time and maybe even cause us to do some simple addition mistakes or multiplication mistakes. But if we did multiply it out, it would look like this. Okay? So taking a look at a plus b to the fourth and its final answer, I want you to take a look at the coefficients. So I'm going to write this guy in. The coefficient here is 1. The coefficient here is 4. The coefficient here is 6. The coefficient here is 4. And then we have 1 again. Now looking at this, I want you then to compare it, the coefficients, to row number 4. And what you'll notice is that in row number 4, and the reason I chose row number 4 is because it's raised to the fourth power, row number 4 actually has the same coefficients. We have 1, 1, 4, 4, 6, 6, 4, 4, and 1, 1. So, in other words, Pascal's triangle is actually giving us the numbers or coefficients when we raise a binomial, two terms, to a high power. So if I ask you, what would be the coefficients of a plus b to the 7th? So we would then look at the 7th row, and we would know that the coefficients would be 1, 7, 21, 35, 35, 21, 7, and 1. Okay? So this is how we're going to use Pascal's triangle to help us quickly multiply these very big problems here. The other thing I want you to look at is, let's look at the variables. So we have a to the fourth, and then we look at the next term. What happens to our a? We get a to the third, then a to the second, then a to the first, and then the a disappears. Okay? So if we did that for 7, instead of a to the fourth, we would get a to the 7th, then we get a to the 6th, this guy would be a to the 5th, a to the 4th, a to the 3rd, a to the 2nd, a to the 1st, and last but not least, this guy would not have an a. Okay, and we got a from the first term here. So I'm using a because it's our first term. Now if we look at this example, what happens to my second term, or in this case the b? So in the first term there is no b, it's gone. But in the second term we have b to the first, b to the second, b to the third, and then b to the fourth. Or in other words, our second term is going backwards in descending order, starting from the end. 4, 3, 2, 1, none. So it goes in the opposite direction of our first term, our a term. So if we did that for 7, 1 would have b to the 7th, b to the 6th, b to the 5th, fourth, third, second, first, and then this b would be non-existent. And then what do you notice about all the signs? We always put plus signs in between. So this pattern that we just did is called binomial theorem. And it's a very simple pattern to see once you have Pascal's triangle. Okay, so we're going to do some problems here in the next slide using this pattern to multiply big numbers fairly quickly. It's a lot faster than trying to multiply this guy out here. Okay? Okay, let's go ahead and use binomial theorem to multiply example C. So it's a binomial. Binomial theorem only works for binomials. Our first term is x. Our second term is actually negative 1y. And that's very important when we start dealing with the signs. And in Pascal's triangle, we are going to look at the fourth row. So again, it's numbered with the first row being 0. So we are really going to be looking at this row. So I'm going to put down those coefficients down quickly. And it's going to be 1. Then we have 4, 6, 4, 1. 1, 4, 6, 4, and then 1. Okay, so these I know are my coefficients. And now I'm going to put in my terms. So we'll do the first term in blue. Okay. And the first term will go, so the blue term will go here, starting with a power of 4, because that's my exponent. So it's going to be x to the fourth. Then we drop down, x to the third, x to the second, x, and last but not least, this guy does not have the first term. Now, the second term, we're going to work our way backwards. So we're going to take our second term, and we're going to start at the end. So my second term is negative 1y. And we'll do this in purple. So we'll have negative 1. So I like to put this in parentheses. Negative 1y to the fourth. Again, parentheses. Negative 1y to the third. Negative 1y to the second. Negative 1y to the first, and then our last guy does not have our second term. Okay, and then in between I'm going to put addition signs, but keep in mind it might not stay addition because we do have some negative signs in there. So addition signs in between, and all we have to do now is clean this up. So we go to the first term, 1x to the fourth, nothing to clean up there, that stays 1x to the fourth. Now we go here, 4x to the third, nothing there, but negative 1y. So what we're going to do here is we're going to do some multiplication. So the whole numbers have to multiply. So we have positive 4 times negative 1, and that's actually going to give me a negative 4. And then we're going to have x third y. So we bring the variables in at the end. Okay. Middle term, before we can multiply the 6 with the negative 1, we got to do this math here. So negative 1 to the second power, that actually gives me positive 1. And then we're going to have y squared. Okay, and now I can multiply it with 6 times x squared times 1y. So if we do this math here, we can now go 6 times 1, that's positive 6. X squared times y squared, that's x squared y squared. Okay, and let's do this over here. Again, order of operations says let's do exponents first. So negative 1 to the third, so that's negative 1 times negative 1 times negative 1. That's actually going to stay negative 1, and this is going to give me y to the third. We can then multiply it with x and positive 4. So 4 times negative 1, that gives me negative 4. And x times y to the third, that's just x y to the third. Okay, and then last but not least, we go negative 1 to the fourth. That gives me positive 1 y to the fourth times 1. Do this math. 1 times 1 y to the fourth. That's going to give me plus 1 y to the fourth. And we now have our final answer here. Okay, so keep in mind, this is my answer. The other thing I want to point out, this guy would be considered your first term, second term, third term, fourth term, fifth term. Okay, so if I ask you what is the fourth term here, you would go 1, 2, 3, 4. This would be your fourth term. Go ahead and do example D. And in example D, I want you in Google Classroom to give me the coefficient of the second term. Put that in our comment section. So again, I want the second term's coefficient for example D. Okay, quickly I'm going to do example E here. Again, we are only looking for the fourth term in example E. So if you notice, I'm using the fifth row, which is this row here. Those are my coefficients. And I only want the answer to the fourth term. So first, second, third, fourth. So I'm really just looking for whatever answer I get from this guy here in the fourth term. Whatever answer I get there, that's my answer to example E. Okay, go ahead and try it. I'm going to complete it, so if you want to pause the video, you can. So again, I only simplified the fourth term. This will be the answer to the fourth term in this binomial expansion. Go ahead and practice with F, see how you do, and we'll go from there.